So in this lesson, we're going to start looking at what makes triangles congruent. So specifically today, we're going to be able to use side, 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 and side angle side to prove triangle congruency. It's going to be a huge part of geometry going forward. Almost every proof from here on out is going to use one of these triangle congruence postulates or theorems. And you'll know you've got this lesson when you can use those properties, side, 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 side angle side, to prove it. So the big goal is we're getting to proofs. We're getting into proofs. So first we're going to look at, can you create congruent triangles from three congruent sides? So if the sides are the same, will the triangles have to be the same? So you're kind of asking, can I take these three sides and make two different triangles? Can I take these three sides and make two different triangles, or will they be the same triangle? So we're going to copy them. I'll start with the green one. We're going to copy that onto this segment right here. So I got the length. Bring it down. We're going to copy it onto this line. That's not green. That's supposed to be green. Green. So that's the green segment. Then we're going to take the red segment. We're going to copy that. So we've got our length there. We're going to bring it down also from the point. We don't know where that side's going to go, so we're just going to make a big arc up there. And then we're going to do the same thing with the blue one. We've got our length. We're going to bring it over to that other side. And we're going to see where they cross. So our blue side had to connect from here. Our red side had to connect to right there. I'll go over them in the colors. There's blue. And there's red. So that's the only triangle that we were able to make out of it. So we're going to do it again. We're going to try to see if we can use these sides differently and get a different triangle. So I started with the green one last time. This time, start with the blue one. So we're going to start with the blue one. I'm going to put the blue segment on this line first. Try to do backwards. So there's our blue segment. From one of those two endpoints, we'll do one of these two sides. So let's go red next. So there's the length of red. And then from one of these two endpoints, it doesn't matter which one, I'll go over here. It doesn't really matter. And make a big arc, because all we know is it's going to be somewhere out there. And then we're going to do the green from the other side. So we'll go green from here out to wherever it crosses. We'll measure our green. We're trying to do it different, seeing if we can get a different triangle. So there's our green length. We're going to bring it down and copy it like we said. From the point. So that made a triangle right there. Connect them so we can see what's what. So this was our green side. This was the blue side, and we did red over here. So now we just need to look, are these triangles the same triangle? So to do that, I'm going to trace this triangle. Now I'm going to grab it. I can see if I can make it match up with the other triangle. So put the green side on the green side. This over here on my right, that's the red side. So the red needs to match with red. So I got to flip this. So the green side with the green side, red side with the red side. And now this would be the blue side. So I need to flip it one more time, make it go that way, reflecting it over that line. But I think now that it's kind of in position, you can kind of tell it's going to match up. I think they got messed up on me. Flipped it the wrong way. I can go back to it. There it is. So from right here, it's kind of hard. I can't make it flip the right way for me. But if I reflect that over, you can see that it's going to match up. They do match up. The red side matches up with the red side now. This would be the blue side, and the green sides are right there. So if you flip that over, they do match up. Those are the same triangle. So the question was, can you create congruent triangles from 3 congruent sides? Yeah, you can. Not only can you, you can't create, it'd be impossible to create 2 different triangles. So it's kind of a long demonstration explanation for this thing right here, the side congruence criterion. Side congruence. We're just going to abbreviate it SSS, side. So when all 3 sides are set, the triangles have to be congruent. So if all 3 sides are congruent to the other 3 sides, no matter what, there's a series of rigid motions, reflections, rotations, translations that will make it match up. So a key part that we're going to be using in all of our proofs is reflexive property. Reflexive property and vertical angles and alternate interior angles are going to be used a lot. One of them, if not more than one, in every single proof. So the reflexive property kind of reminds me of the word reflection, because when you look in the mirror, you see a reflection, you see yourself. Reflexive property is saying that something is congruent to itself. And that's going to be useful when 2 triangles share something like a side. Could be an angle, but usually it's side, but it could be an angle. So here are, we'll start with these 2. Those are 2 triangles. and they share a side. They share this side right here. When that happens, that's when you use the reflexive property, because you know that they both have that side EP. So you already know one piece of those two triangles that's congruent to itself. You know that EP is congruent to itself, to EP. And EP is a corresponding side from those two triangles. On this other drawing, this still happens. It doesn't happen as often, but it still happens where there are two triangles. We've got the small triangle, and then we have this bigger triangle. But they have one part that's exactly the same, and that's right here, angle O. They both have that angle. That angle is the exact same in both of them. So if you're using reflexive property for that, you would say angle O is congruent to angle O. It's always going to be the same thing on both sides of the congruent symbol. That's the reflexive property. You're looking for something that they share that you can say is congruent to itself, and is part of each triangle, part of both triangles. And again, that's called the reflexive property. So on the first page, we said that one of the ways that you can know that two triangles are congruent is by the side congruence criterion, which just says that if all three sides of one triangle are congruent to the three sides of the other triangle, they have to be the same triangle. They have to be congruent. So here's two triangles. And we've got some markings. We know that OG and LF are congruent because they're marked, one arc apiece. We know that OL and GF are congruent because they're marked. So that's already two sides of our first triangle congruent to two sides of the other. And then right here in the middle, we have side LG, which is in both of those triangles. And therefore, it's got to be congruent to itself. It's in both triangles. So that's our third side right there. We have all three sides of triangle OLG are congruent to all three sides of triangle LFG. So when we go to name this, though, we need to name it carefully. We need to say it in order. That was the big part of yesterday's lesson. It's still a big part. Whenever you name, you have to name in corresponding order. So that means that we need to match up our sides. Side OG needs to match up with side LF. And of those two letters, O and F are going to have to match up. Because to make this work, if we were looking for a series of rigid motions that would make this work, we would trace it out. And then we would try to figure out how to make this work. So it's not going to be a reflection. It's going to be a rotation to make these match up to each other. So if I rotate this around, then we can see that it matches up. So when we rotate, point L rotates around and matches up with L rotated all the way around over here to G. So when we start with L in the other triangle, we have to start with G because L matched up with G. And if we go from L to F, look where F started. over here, bottom right. You rotate it around, it's going to go and match up to O. The second letter we wrote was F. The second letter we're going to write is O. And then you can pretty much apply the same thing. That then point G, when we rotated that around, it went way over here to L. So G went to L. You have to name them in order. So since we went L, F, G, we had to go G, O, L. L, F, G, G, O, L. Have to name it in corresponding order. And the easiest way to do that is to see if it's a reflection, if it's a rotation, what is it going to be that's going to match it up. So, yes, they're congruent. We said they're congruent. They're congruent by side, side, side. So all three sides of one triangle are congruent to all three sides of the other triangle. And then specifically those three sides, we knew that side LF was congruent. This is what we did yesterday. LF was congruent to GO. That's one side. We knew that because of the markings. We knew that side LF, how about FG, was congruent to OL. Again, because of those markings. And then the third side, since it was side, 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 we need to be able to write side, side, side. Three sides. The third side was this one right here in the middle. LG, congruent to itself. Technically, we should write GL, though, so that it goes in corresponding order. Since we did it, LG, the first and third letter, needs to be the first and third letter. But that's by that was reflexive, just to remind you what that word is. So this one was given, it was marked. This one was given because it was marked. And then the third side we got from the reflexive property, which proves that these are congruent by side, side, side. That's actually all the information that you're going to need for a proof. I just didn't do it in 2 columns. I did it more of a flow proof. So are the 2 triangles congruent? If N is the midpoint. So if N is the midpoint, midpoint means it's right in the middle. The 2 sides are equal. So if that's the midpoint, that means these 2 sides are equal. So that's one side. We have a side of each triangle, one side of each triangle. Then, looking at these 2 triangles, you can trace them out and you see that they both have side YN. And that's congruent by the reflexive property. That's 2 sides. If we know the third side, then we know that they're congruent by side, side, side. But we don't know the third side. There's nothing else that we know from this picture. So we need to know one more thing. We've got one side, we've got 2 sides, we need the third side. The third side that we would need would be these. We would need to know that YR is congruent to YA. And that wasn't told to us, and there's no way of knowing that, so we don't have enough information. You need to be able to put the marks on all 3 sides, and we couldn't put these purple ones. Nothing told that to us. So what do we need to know? We just wrote it down. That's actually what we just wrote down. We had to know that YR was congruent to YA. So for the next piece of these that we're going to be talking about, we said we're going to learn side, 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 and side angle side. You got to know this word, the included angle. The included angle is the angle in between. So if you put your fingertips together, you draw fingers this way and fingers this way, you make an angle. The angle between your fingertips would be the included angle. Whenever there's two sides, the angle between those two sides is the included angle. Two sides meet at the same vertex. So if we're looking at these two sides, L would be the included angle. If we're looking at different sides, it would be a different included angle. If we looked at EF and LF, it would be F would be the included angle. And then the included side, included just means between, basically. So included side is the side that's between two angles. So if we pick two angles, these two right there. The side is, the included side is the side that links those two angles together. So if you connect, so we're talking about angle E and angle L, the side that links them together is side EL. So included just means between. So we're going to kind of do the same thing that we started with side, side, side. We're going to start with a side and an angle and put the other side. So I want to start by copying the angle. And we're going to copy it right here onto this point. So we already have the one side drawn out. We need to copy our angle now. So we're going to do that with our compass. And when you copy an angle, you stretch out your compass so that it will still touch both sides, like that. And we're going to make that same arc from this point down here. Then we're going to measure from those 2 points where it intersected. And that's going to make an X over there. We're going to make that same exact X on this arc. So that angle has to go through there like that. And now we're going to copy the sides. We're going to copy the blue side. That's how long the blue side is. Let's put the blue side on the bottom. Doesn't really matter. Copy the blue side onto the bottom and ends up over here. Then we're going to copy the red side onto the side that we created over here for the angle. Measure it out. Barely made that long enough. So that makes our triangle. All we got to do is connect these two sides, or these 2 points. There's our triangle. So we're going to do the same thing. We're going to use that angle and those two sides. I'll switch them around this time to try to make it a little bit different. So here's our point. Last time I did blue along the bottom and the red going up. I'll switch that. We still got to start with the angle though. We're going to copy that angle. So that means we need to, I'll just go back to where we did it before. There's our first arc. Right there. Copy that onto our point. And then measure the opening of that angle and copy it down. Measure the opening and copy it down here. So our angle has to go that way. So last time I did blue on the bottom and red on the side we created. I'm going to flip that, see if we can make a different triangle. See if it changes anything. We'll do red on the bottom this time. Red on the bottom. And we'll do blue on the other side. So that makes a triangle. Right there, makes a triangle. So we're looking now to see, are they the same triangle? Could it be reflected, rotated, translated all around? I'm going to highlight both of this triangle that I just made. So there's that triangle. Now, I should be able to do some sort of sequence of rigid motions that's going to make this match up. So I'm going to, I think I need to flip it left, right. So what that did is that made our blue side come to the right. So now I'm moving the blue side to the bottom because that's what we did before. It made our red side go over here, I think. This should match up. Right there. So they are the same triangle. They are the same triangle. No matter what, when you have two sides and the included angle. So that means when we have the angle and we did a certain length on the right and a certain length on the left, you are guaranteed to get congruent triangles. That's what SAS means. When you have two sides that you know are congruent and you know the included angle is the same, the triangles have to be congruent. So really what we're doing is we took what we learned in our last lesson, yesterday's lesson, about how triangles are congruent if all of their stuff is congruent. That's what we said yesterday. If all three angles are congruent to the other three angles and all three sides are congruent to the other three sides, those two triangles have to be the same. What this does, what SAS does, and what SSS does, is it's a shortcut. You don't need three angles and three sides. You need three things total. Either the three sides, or in this case, two sides and the included angle. So it's a shortcut. It's a shortcut to know that triangles are congruent. So we've talked about vertical angles before. I mentioned it a couple minutes ago in this lesson. Vertical angles is going to be used all the time in these proofs. Reflexive or vertical will be used in almost every single proof. So remember, vertical angles are when two angles or two lines intersect. The angles that are across from each other in that X, so here's our X, the angles that are across from each other are vertical angles. And vertical angles are always congruent. So that will help to be the angle maybe between the two sides for side angle side. So for this proof, we're going to look to see if we can prove that they are congruent. We've got two things in our tool belt. We got two ways of proving triangles congruent. Side, 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 and side angle side. So if we know all three sides are congruent between the two triangles, we can use side, side, side. If we know two sides and the angle in between them is congruent in each triangle, then we can use SAS. So what we're doing is we look first at the picture to see what we know. We also look at the words to see what we're told. So you look to see what you can see and you look to see what you're told. YT and SL bisect each other. That means they cut each other in half. Bisect means cut in half. So if YT cuts SL in half, YT cuts it right here. So that means we get these two sides. Those are the two sides that it gets cut to, and those are equal. They're congruent. Mark it. And then we're going to do the same thing with the other one. If SL cuts YT in half, so here's YT, and it gets cut right there. It gets cut in half. That means these two sides are congruent. So in this bisect each other statement, we got a couple of congruent pieces. So that's what we're told. Then you look to see what else you know from the picture. And we just talked about vertical angles because right here we've got vertical angles. So we had two sides of this triangle congruent to two sides of the other triangle. And the angle in between is congruent. That is side angle side. That's what side angle side means. We have two sides and the angles in between. Since it's two sides and the angle in between, that's why the A is between S and the S, because we got the two sides and the angle has to go between them. So the order that you write SAS matters because it tells you that the angle has to be between the two sides. So we're going to look at these two triangles. We're looking for what we're told and we're looking for what we see. Doesn't really matter which way you attack it. If you want to start with what you're told and then go to what you see, that's good. If you want to start with what you see and then go to what you're told, that's good too. So MT is the angle bisector to AMH. Here's AMH. MT is the angle bisector. So MT cuts that angle in half. So that means it makes two equal congruent angles. I'm going to mark those two angles. Since it's a bisector, it makes them congruent. These two angles, horrible. These two angles are congruent to each other because it was bisected. It was cut into two equal pieces, two equal halves. And then we know something else from the picture. There's two triangles. They both have this side right here, MT. That's called reflexive property. And that's it. We've got one angle in each triangle. We've got one side in each triangle. That's all we got. That's not enough. That's not enough. You have to know three things from each triangle. Either two sides and an angle, three sides, whatever. You have to know three. We only know two. We know an angle and a side. So what else would we need for side angle side? So we've got the angle taken care of right there. We've got the side taken care of right there. So that means we need another side. And it has to be the side that the angle is in between. So right now we know this side, and here's our angle. So the side that makes that angle be included is right next to it. And we got the two angles, or the two sides and the angle in between. And then that would match up here. Here's the side, there's the angle, that's the other side. That's what we would need. AM and HM. Since this, you can see, if you folded it over that dashed line, it would be, if you reflected it over that dashed line, they'd be congruent, which tells you how everything's going to match up. A is going to match up with H, M is going to match up with M. So when you name it, you got to name it so that they're corresponding. You need AM to be congruent to HM. That's the other piece of information that you need. So I talked about how it's important that the order that you write these things tells you that the order that they happen, like that the side is included and that sort of thing. This is going to demonstrate it. So we're going to do the same thing. We can do the, we need the angle, and then we're going to do the two sides also. But the two sides are not going to include that angle. So we're going to put the angle here. We'll build a side off of it, and then we'll build the other side off of that and see if we get a triangle out of it. And we'll do it again and see if we get the same triangle. Oh, I'm going to start with the angle. It doesn't really matter, but starting with the angle is a good idea. So make your arc. And then we're going to come down here and we're going to copy that. You measure how big that angle is along that arc. And we copy that. So there's our angle. Now we're going to copy the two sides. I will do the blue side first. And then next time, just to see if it makes a difference, I'm going to try the red side next. So there's our blue side. Stops right here. Now we'll do the same thing for the red. Whoops. So it marks way out there. You can draw more of this and see if it touches anywhere else. It doesn't. So that's our only triangle right here. So there's our triangle. Now we're going to do it again. We're going to copy the angle, and then we're going to do the red side first, because we're trying to switch it up. Let me go back to green pen. So there's our arc that we made. We're going to copy that down here. Then you measure that opening. And there's our angle. So I'm going to make this. So on the last time we did this, on that first construction up top, we did the blue side first. So this time I'm going to start with the red side, see if it mixes anything up. So far, we've yet to see one where that happened. So here's our red length. Copy it down here. We start red this time. And then from there, we're going to measure our blue length and make that be our third side. So there's our blue length. So we're going to come over here. And we can see it crosses right there. But just like I did before, we want to keep going with that to see if anything else happens. And this time something did happen. Before, when we did that with the red, it kept going and it kind of went over here somewhere and missed. It didn't make a triangle out of it. This time, it hits it 2 times, which means we have 2 triangles. We have 2 triangles. We've got this big one, which doesn't look congruent to what we started with anyway. And we also have that small triangle, which is definitely not congruent to what we said. So what that means is that when you have an angle, because these angles were congruent, this side was congruent to that side, and this side was congruent to that side, they don't make the same triangle though. So when you have 2 sides and the angle's not in between, it doesn't work. Side-side angle does not work. There's no side-side angle. Or for that matter, if you switch those letters around, it wouldn't work either. And it's not just because that's a bad word, but it doesn't work. So, SSA, even the other way, if you put the A first, it doesn't work. No matter what. 2 sides and the angle not in between does not work.